Hey there, science fans! Have you ever wondered how Netflix seems to know exactly what shows you'd like, or how your phone can unlock just by looking at your face? It's all thanks to the amazing power of machine learning. Machine learning is like teaching computers to learn from information just like you and me. But instead of textbooks and lectures, machines use data, tons and tons of data. This data helps them find patterns, make predictions, and even learn from their mistakes. Think about a robot learning to play a video game. At first, it might be all over the place, but as it plays more and more, it starts to understand the rules, the strategies, and even how to outsmart its opponents. That's machine learning in action. There are three main ways machines learn: supervised learning, unsupervised learning, and reinforcement learning. Let's dive in and explore each one. Imagine you're teaching a dog to fetch. You throw a ball, say, "Fetch," and your furry friend learns to bring it back. That's kind of how supervised learning works. In supervised learning, we give the machine a bunch of labeled data. Think of it like a giant stack of animal pictures. Each picture is labeled as a cat, dog, bird, and so on. The machine looks at these labeled pictures and learns to recognize the patterns that make a cat, a dog a dog. Once it's trained on enough labeled data, you can show it a brand new picture of an animal it's never seen before, and it can hopefully tell you what it is. Supervised learning is used in all sorts of cool ways, like spam filtering. Your email inbox can tell which messages are junk mail by learning from millions of emails that have already been labeled as spam or not spam. Medical diagnoses. Doctors can use machine learning to help them diagnose diseases earlier and more accurately by training algorithms on huge data sets of medical images and patient information. And predicting customer behavior. Businesses use supervised learning to understand their customers better, predicting what they might buy next, or which ads they're most likely to click on. The good supervised learning is great for tasks where we already have a lot of labeled data, and we want the machine to make accurate predictions based on that data. The not so good, it can be tough to get enough labeled data to train a supervised learning model well. Plus, these models can sometimes struggle when they encounter something completely new that wasn't in their training data. Imagine you're a detective at a crime scene. No one tells you what happened, but you have to piece together the clues. That's unsupervised learning. The machine gets a pile of data, but no labels, like a jigsaw puzzle with no picture on the box. It has to find patterns and relationships all on its own. For example, clustering. Imagine sorting a bowl of mixed marbles by color without being told how. Unsupervised learning powers product recommendations, detects fraud, and helps businesses understand customers. It uncovers hidden patterns, but results can be tricky to interpret and evaluate. Think about how you train a dog. You give it treats and praise when it does something good, and maybe a little no when it does something wrong. The dog learns from these rewards and punishments, figuring out the best way to behave. That's the basic idea behind reinforcement learning. In reinforcement learning, we let the machine loose, in an environment where it can interact and learn through trial and error. The machine takes actions and receives rewards or penalties based on those actions. Imagine a robot learning to navigate a maze. It starts by wandering around randomly. If it takes a wrong turn, it might bump into a wall. Penalty. But if it finds the right path, it gets closer to the exit. Reward. Over time, it learns to maximize its rewards and avoid penalties, becoming a maze-solving pro. Reinforcement learning is used in some pretty amazing applications, like playing games. Reinforcement learning has been used to create AI agents that can beat even the best human players at complex games like Go, chess, and even video games like StarCraft. In robotics, robots can use reinforcement learning to learn how to walk, grasp objects, and navigate complex environments, all without needing humans to program every single movement. For personalized learning, educational software can use reinforcement learning to adapt to each student's individual learning style and pace, providing personalized lessons and feedback to help them learn more effectively. The good reinforcement learning is super powerful because it allows machines to learn complex tasks in dynamic environments, even when there's no labeled data available. It's all about learning by doing. The not-so-good reinforcement learning can be computationally expensive and time-consuming to train, especially for complex tasks. It can also be tricky to design the right reward system, as poorly designed rewards can lead to unintended consequences or suboptimal behavior. So there you have it, folks. The three main types of machine learning: Let's recap with some easy-to-remember analogies. Supervised learning is like learning from a teacher who gives you the answers. Think textbooks and quizzes. Unsupervised learning is like being a detective solving a case with no clues. Think puzzles and patterns. Reinforcement learning is like training a pet with treats and praise. Think rewards and learning from mistakes. Each type of learning has its own strengths and weaknesses, making them suitable for different kinds of problems. Well, that's machine learning in a nutshell. I hope you enjoyed learning about these incredible technologies that are shaping our world. But this is just the beginning. There's a whole universe of exciting discoveries and possibilities waiting to be explored in the world of machine learning. So keep asking questions, keep exploring, and never stop learning. And hey, maybe someday you'll be the one teaching machines a thing or two.